Welcome and thank you for joining us. The traditional thinking around water is what we call the linear approach. We have the catchment area, we treat it to potable standard, we use that for irrigation, we use it in buildings, discharge it to often overloaded municipal wastewater networks, wastewater plants, and then into a water course. The new way of thinking is what I call the circular approach. So we have the catchment, we still treat to potable, and we still use it in the building. But whatever comes out of the building, we treat it on site, we take it back into the building for non-potable applications, and or we take it to irrigation or other outdoor use. Now you have less discharge to the municipal system, if any, so you reduce the load on the overloaded networks and you reduce the waste to the water course. But because you now recycle on site, you lower your demand of potable water. That means that you have more fresh water in your natural dam system. And you can actually release some of that water if water is needed downstream. So instead of having a pollution effect like we have here and that water goes into the river, we now recycle on site and we can release pure water into the river, which will improve the entire cycle downstream. So the product that I'm referring to is the Clarus Fusion, and you will see how that will solve water problems and wastewater problems, including pollution of our water courses. There's just 2 or 3 technical slides. There's more technical information available, but we don't have the time for all of that today. The Fusion is a factory-built moving bed biofilm reactor. That's similar technology that's often used in large municipal plants. It's not the standard MBR, not a membrane bioreactor, but it's a moving bed. And it follows the same treatment process, your activated sludge process that you find in the large plants, including biological nutrient removal. And this is very important because many of the smaller plants, also known as package plants, often cannot do biological nutrient removal. And if you don't remove your nutrients, you get algae bloom in your rivers and dams. So that is a very important step that should be part of the treatment process. So whenever comparing technology, it is always good to see if that technology can do BNR. The system consists out of 3 components. You have the bioreactor that's underground, electrical panel that's above ground, and an air pump. And those 3 together will do the treatment. We're getting back to these 2 a little bit later, first focusing on the bioreactor. What differentiates this from many of the other systems, and also things to keep in mind when you compare: low power consumption. We're talking on the larger plants 0.55 kilowatts per kiloliter of water, which is extremely low energy consumption to treat your wastewater on site. It's a single tank, as you've seen, completely underground installation, so it's out of sight. But also that is practical because the underground installation insulates the system, especially where you have low night temperatures in winter or very high day temperatures in summer. Because the bacteria in a wastewater treatment plant prefer temperatures between 7 and 30 degrees. So the soil also acts as an insulator. Low noise factor. If this system had to be running here now, you wouldn't hear it. Even if I keep quiet for a while, you won't hear it. That's how quiet it is. And we get into that a little bit later. Easy installation because it's factory built. You're not reliant on on-site construction of the unit. It's fully built, dropped in on site, 4 pipe connections, and you're up and running. Low maintenance, and that's a very relative term. Low maintenance in this case means only 1 hour every 6 months. For 6 months you don't have to look after the unit. Then you go there, you spend 1 hour with it, and you leave it alone for 6 months again. This is what we call low maintenance. There's no downtime. So even while the plant is being serviced, the building can operate as usual. The alarm panel, you've seen that, we will get into a bit more details. Biological nutrient removal is part of the treatment process. a very, very small footprint. We're looking at a 15 kiloliter per day plant having a footprint of 4.8 by 2.5 meters only. And then solar options are available because of the low power consumption. So it's not a DC system, it's an AC system, but it's easy to run off solar because of the extremely low power consumption. If you get into the technical side, it's a 3-chamber plus then a clarifier at the end. Your first chamber is pretty much what you will find in a septic tank when you get your solid separation and fermentation that starts happening there. Your fatty matter, now this is not a grease trap, but your normal body lotions, your body fats, etc. will flow to the top, your solids will drop to the bottom, and you will get fermentation that starts happening there. In the second chamber, to grow more bacteria for the treatment, we include bioballs, and the bioballs create surface for the bacteria to grow on. The problem with media is always that you need to remove it and clean it from time to time. Now in this case, the media is in a suspended cage, suspended off the floor, so you never need to remove the media because everything that cannot degrade will settle down on the floor, and going through that chamber at the back there, that chimney, you can actually desludge the second chamber. How do you know when to desludge it? That's part of the servicing, is to measure the sludge depth, and the sludge depth at the time of servicing will tell you whether it is necessary to remove sludge or not. Typically we find desludging between 4 and 6 years. We get some abusive situations where it needs to be done more often, and we get some cases, especially where seasonal occupation is, that we go up to 10 years without desludging. So there is no fixed time period. The sludge depth test during the servicing will tell you whether that's necessary. But these balls cannot be removed once the system is fully assembled. Then in the third chamber is where things get really, really interesting. Air is introduced through the blue line there, and that air is coming from the air pump that is situated outside the unit. The air pump is also the only moving part. So with the aeration, you get CO2 reduction and you get nitrification of ammonia. Ammonia coming from urine, from sweat, from cleaning detergents, etc., etc. Now this is the moving bed that you will see here. And the reason for the moving bed is in the third stage with the aeration, a byproduct is sludge. Hence the term activated sludge plant. And this sludge will again clog media. But the moving bed ensures that the media actually scrub itself and keep itself clean. Now the water will carry that sludge down to the bottom of the chamber before flowing up through the clarifier, and that sludge is then handled twice a day, which you will see 2 slides from here. Sorry. The aeration, as we said, CO2 reduction, nitrification taking place. And this is where most small plants treatment stops. You will see a few more steps in this specific one, but this is where most stop. So you now still have a nitrogen problem because you've got ammonia, first change to nitrite and then nitrate, but you still have the same amount of nitrogen in the system. That is what it looks like. You will see the media there, thousands and thousands of those little pipes, and then the active aeration taking place in this chamber. Now, for the purpose of the next 2 slides, have a look at the blue line with the grey valve, and then the red line with the grey valve connected to that. We will explain that just now. The actual valves, the blue and the red, are basically to balance your airflow between left and right. In case the plant goes slightly out of level, then you can adjust your airflow to ensure that you get even airflow throughout the chamber. Now, during the aeration cycle, which is the blue line, a little bit of water will be airlifted from the clarifier. Now, this is where the Americans confuse everybody, because they start off by saying there are no pumps in the system, and at this point they talk about an airlift pump, and everybody's confused. The airlift pump, that is airlift from the air pump outside. It's not the pump that's in the system. So you have your airlift happening there and return back into the first chamber. Now, having that set at a very specific rate, you will get denitrification because you now have your nitrate-rich water that goes back into the first chamber where oxygen is absorbed in the fermentation process. And you're then left with nitrogen, which at room temperature is a gas, and it will evaporate to the atmosphere. Together with that, you inoculate your first chamber with activated bacteria. Because you see what happened, you will typically have cycles. If it's an office, you have a day cycle. If it is a domestic setup, you have a morning and evening cycle, where you have high flows. In a high flow period, you will wash your bacteria out of the plant, and that is not good for any system. So what this one does is it takes activated bacteria from the third stage and bring it back to the head of the tank to treat the sewage that come in. But during the low flow period, you pre-treat the entire volume of the plant. By returning clean water to the front, you start pushing dirty water through the system and you continue your treatment process even though there's no inflow. And as long as you keep your nitrates between 2 and 6, which is within the legal limit, then you get organic binding of phosphates. Phosphates can also be removed with ferric and other chemical dosing, but in this case it's an organic process. And this process, although this technology was imported from the US, the process of organic phosphate binding was actually developed in South Africa by South African people, the Water Research Commission, and people like Dries Low, who was CEO of Arvat at the time. Then the system will automatically switch over from blue to the red line twice a day, and it will then airlift the sludge that is now at the bottom of the third chamber. So that prevents the third chamber from clogging up, and you get a sludge return back to the head of the tank where the sludge is redigested internally. Now this is very important because that reduces your sludge removal intervals. You don't just pump it out of the third chamber, you redigest it internally. But even more important, when you're dealing with schools, when you're dealing with the hospitality industry, or any other application where you have seasonal trends, if you look at the through-flow system, your bacteria will start starving after 2 weeks of no inflow because there's not enough food for them. This system takes the sludge from the third chamber and feed the bacteria in the first chamber. So what you will typically find is in a high season, let's use a school as an example. During the school term, you will get a buildup of sludge. During the school holiday, it will deplete its own sludge because it uses that sludge as a food source. And that is why in that kind of application we have plants that's been running for 11 years now without having to be desludged. But there's another very important fact here, is this system can go for up to 6 months without any inflow and the bacteria will remain alive. Again, think of a school. You have 2 short holidays, but you have the winter holiday that's normally longer, and you have December that's 6 weeks long. By the end of that 6 weeks, you hardly have any living bacteria left in a single through system. While in this one, you will still have a very strong colony when the school starts at the beginning of January. And this is very, very important because it ensures good quality of water throughout the year. Right at the end, you will have the clarifier, the 12-step, and the clarifier will settle out suspended solids. And by design, that suspended solids will also flow down under the third chamber, and that is picked up with the sludge from the third chamber and returned back into the head of the tank. Factory setting is to do sludge return twice a day, but it can be manipulated on site to be done 3 times or 8 times, or however often it needs to be done according to site requirements. And then lastly, we need to disinfect. We cannot disinfect the water in the system because we need the good bacteria to digest the wastewater. So once treatment is done, then we go for disinfection, which can be UV, chlorine, ozone, or on farms, sometimes peroxide is used as well. I prefer not to use that in the cities because then everybody knows how to handle peroxide. but it's possible to do that if you have an application where there's already peroxide on site and they have the safety measures in place for that. The air pump is the only moving part that aerates the fusion 24/7. It airlifts the water for the internal recirculation and for the backwash, and extremely low power consumption. This is also the only part that needs to be maintained as far as spares are concerned. Every 6 months you will clean the air filter in really dusty areas, maybe a little bit more often, but the diaphragms will be replaced every 4 years. And those are the only normal service replacement parts that's required for the entire system. The electrical panel will supply power to the air pump, UV, and if any pumps are needed to pump wastewater to or from the system. It also monitors the system 24/7. For instance, if the air pump would fail, then the red light will come on, the strobe light will come on, and there is a siren inside the panel as well, and that will say blow or fail. So you now need to act on that. If for some reason the backwash system, internal backwash system has failed, then the amber light will lit up and it will tell you backwash fail. If there's a blockage inside the system, the green light will indicate high level fusion. So you know there's a blockage in the system, it needs to be unblocked. And then if there's a pre-screen to remove inorganic matter, and there's a blockage in the pre-screen, the blue light will tell you screen high level. And somebody needs to open the screen, remove the blockage from the screen, and the system will operate as normal. So you don't need somebody to go and check on it regularly. It's self-monitoring, and the output of this is 12 volt DC, which can be connected to any remote monitoring. It can be included in building management systems, home automation, GSM, whatever remote monitoring may be required. There's many different apps available for that as well. The enclosure is IP65 GRP. Why GRP? We're dealing with sewage here. We don't want to deal with steel that can rust. And then, as we said, remote monitoring is optional. At this stage, I want to look at a few case studies. The first case study is the Department of Environmental Affairs. Now, I actually wanted to ask you a question before the slide and I forgot. But if for one moment you close your eyes and imagine you haven't seen this, just by a raise of hands, how many people would think that in the heart of the city, in a high density building, you will treat sewage? Show of hands, how many people would normally attempt something like that? One? Only one? Okay. Now, I'm going to show you that it's possible. Not only possible, but sustainable as well. So we're looking at the city centre. You will see there's the Cape Town Gardens just as a point of reference. Adderley Street, Wall Street going up there. And we're looking at the building there. You can see it's a high density with very, very little space. We only have a quad in the centre there. Now, we're not treating the wastewater for all of this. We are focusing on this building here, being number 1 and 3 Dorp Street. And that happens to be the building of the Department of Environmental Affairs. So that's very good to keep in mind when you have an application. So guys, you are using it. Environmental Affairs in Cape Town treat their own wastewater on site. If you want a good case study, this is one. If you look at the street view, getting access to that building, you can see is almost impossible. And then we have this quad in the middle of the buildings there. They were revamping the building at the time of installation, and we physically had to carry the plant through the building. So whereas with the volume generated here, normally one plant would do the job, we had to make use of 4 smaller plants because they had to be carried through the building. We couldn't get a bigger plant through there. And that again comes to design. So we can plug and play and we can modify according to site conditions to solve a problem. There's a splitter, and the wastewater is pumped through the splitter to evenly distribute through the 4 plants, from where it is then reused in the building. You can see the construction there, and the final grade looking like this. This is the door to the boardroom of Department of Environmental Affairs. Ladies and gentlemen, we're treating raw sewage 2 meters away from the boardroom of Environmental Affairs. Does that get you thinking?
Must be good.
Coming back to the question, what do you do with the air pump? There's the air pumps and the electrical panels, they're nicely hidden away. So you can't see those lights, but this is connected to the building management system, and they will pick up through the BMS if there's an alarm. In this event, the audible sirens were also disconnected, because you don't want the siren to go off while there's a meeting on in the boardroom, but they will pick it up through the BMS. Service hatches, you can see 1, 2, 3, 4 plants there with the service hatches. And then we use that water to flush the toilets again. Now in this case, this is the only grid-tied installation to date. We've done about 320 of these systems, and this is the only one that's tied to a sewer grid. All the others are 100% off-grid. You have a header tank on the roof of the building that supply water for toilet flushing. So you have a dual pipe into the building. You have a potable water for the normal cold water use, and you have a different piping system that feeds the cisterns. But you only have one discharge. You don't have to split your discharge, because we collect grey and black water for reuse purposes. All wastewater is discharged to lifting station number 1 in the basement. And if that tank has sufficient water, the untreated sewage will simply overflow to the municipal line. When the tank level drops to 80%, it demands wastewater from lifting station, or treated effluent from lifting station 4. Lifting station 4 in turn demand raw sewage from lifting station 1. We literally pump the sewage through the ceiling of the ground floor, through to the treatment plants in the quad. Disinfection, lifted up and reused for toilet flushing. Low dose chlorine, it's got to be very low, because the chlorine is coming back to the system here. We don't want high counts of chlorine, but the low dose chlorine will ensure that the water stays fresh and you don't pick up odors in the toilet systems. And 100% of the toilet flush water is on-site treated. In the case of this building, it's a 50% water saving on the building. 50% still is discharged to the municipality, but the entire need for the toilet flushing is coming off recycled water. Remember what I said in Gauteng? The company had to close because they couldn't flush toilets. There's your answer. Now they can keep the toilets flushing, the building can operate. You can buy water from the local store for making coffee, but it's a bit difficult to buy water from the local store to flush the toilet. Become a little bit expensive. This is a solution. So we're not even talking price here, we're talking a solution that can ensure the building remains open. For other installations, you can easily install it in public open spaces. Here you will see just after installation, this is about 3 years later, you can hardly see the plant. That's the quality of effluent that we're getting out of that plant. And you can see the false rock there covering the air pump. That's another case study there. We had the one behind the false wall. Here we have it covered with a false rock, fiberglass rock, to just blend it in with the rest of the garden. This one is at a commercial building, Barloworld Caterpillar Maputo, and the system is installed in the walkway in front of the parking area. So you don't lose any space, and this is very important when it comes to developments, because every square meter is worth money. If you need to lock out square meters for a wastewater treatment plant, that's lost revenue for the developer. In this case, you don't have to lock out any land for your plant, because you can install it underground in areas that would normally not be used for erecting the building anyway. Here you have the hospitality industry flowing down to the plant, and the treated effluent goes to the irrigation dam. This is a farm outside Stellenbosch. The plant is right below the farm manager's bedroom window. Gava Anderson camp in Namibia. Here we have a very good case where they used to discharge the treated effluent to the veld, and they stopped that. They now discharge it within the perimeter fence, because the elephant didn't go to the watering hole anymore. They came to this pipe and to drink from this pipe here. And the guests were complaining that they don't see any elephant at the watering holes. Now, my understanding is that elephants are always looking for the best quality water. Kiro School in Bloemfontein, we've done more schools, but this is as a case study, where those two plants, and coming back to the organic load here, the hydraulic load for these two plants is 30 kiloliters per day. But because it's a school, because we have a high organic loading here, very little grey water, we reduce the through flow to 15 kiloliters per day. You see how we compensate for the different loading of the water. And that is what we can help you with those designs. And that treated effluent goes to the tanks here, and it joins with the tanks at the back there and used for irrigating the sports fields. Chlorine and UV is used for disinfection. Now, the nice thing for this school is they've grown significantly since the installation 3 years ago. And next year they will breach the threshold of the throughput of the system. What we then do, we split the flow into 3, not into 2, and we add another one. So they don't have to go back and redesign, you just add on as the need increases. And this is very important for future cost of any development. This, I told you 3 weeks ago, I traveled through parts of the Free State and Northern Cape. I took a sample directly from the tail end of the plant. That's a picture that I took with my phone. There's no editing or anything done there. This is the effluent after 3 years in operation. There are other areas where it's not looking that good because of abuse. I'm saying if you use the plant and if you size the plant properly, this is what you can expect out of it. Above ground installations in these rocky areas where it's not possible to dig in, above ground installations will typically be boxed in, or you can just have a berm, a sand berm, and plant it. Just cover it up, hide it away, it looks nice, and it also insulates the system. For developments, you'll see this development is divided into phases, which you will often find. And we install this in the public open space of each phase. So the developer doesn't have to fork out 10 or 20 million rand up front before the first person can take occupation. You can literally start with one system that can handle 20 houses or 4 people. Once you get to house number 21, you install the next one. At house number 41, you install the next one. And that you can actually stretch the cash flow of the developer in that way. Also, you decentralize not only off the municipal grid, you decentralize within the actual development, which shortens your pipe runs. This is also a solution for informal settlements. And I'm going to stick out my neck here and for the chances somebody may cut it off now. Of everybody sitting here, if you visit a construction site, who is happy to use the chemical toilet on that site? Who wants to go to that chemical toilet? Nobody. But we supply chemical toilets to neighborhoods, to informal settlements. Here we can offer dignified sanitation, but the best of all, we don't need potable water, we use treated effluent to flush those toilets again. But even more, we can now harvest the grey water, because what happens in the grey water with an informal settlement? What happens with the grey water? Chucked away. Now we can harvest that grey water, bring it into the system, and we will have excess water that can be used to the benefit of the community. Whether you irrigate a sports field, whether you plant a garden, whether you plant a few trees. Lucerne, whatever the case may be, you now have treated effluent that can positively make a big difference in the lives of the community, while at the same time you offer dignified sanitation. This is a Shell Ultra City Lubatsi border post, the treated effluent after a year in operation. Here you can see the panel and the air pump is outside. So the air pump can handle rain from above, but it cannot be submerged. So wherever you install it, if it's outside, just make sure you've got enough runoff so it's never submerged even during a rainstorm. This is a mining village outside Mahuni in Botswana. There you can see the panel. The air pump is to the bottom here. That's the pre-screen and the treated effluent while I was on site. You will see this brownish color here, that's a reflection from the sand at the back, it's not the water. You can see the color of the water changing the same as the background. And this restaurant in McGregor, I must say this customer was more bold than what I would have been with my own system. Imagine you're going out with your family for the night. You go to a restaurant and without thinking twice, it's a nice summer evening and you go and sit outside and you have dinner. Now you get up, you walk to the loo, you see these funny answers, you don't really care about them, you walk over them, you use the loo, and as you get up, you'll see a notice that say they irrigate the garden with treated effluent. They've got a biological treatment system on site. You go back, you enjoy your dinner, but while you're sitting there, the pump comes on and they irrigate the garden with treated effluent. They don't have a holding tank for the treated effluent on this side. If you want to know if there's any odor, here's your answer. That restaurant is still open.
But there's not a lot of people there. They all died.
You'll be amazed how many people are there. It's quite a popular restaurant, I must tell you. But of extra flavor in the steak, but actually on this side we did have an odor problem. At startup I went through and I realized this is not coming from the plant. And it took us about an hour to find it. What actually happened is the vent pipe from the plant goes up in the corner where this building joins up with a boundary wall. There's a vent pipe going up to the roof of the building. That is the vent pipe from the plant. But they joined the vent of the toilets into the vertical pipe. But the vertical pipe is 110 millimeters, the toilet pipe is 50 mil. The plumber didn't have a boson strap with him. So he drilled a couple of 6 millimeter holes, cut them out, pushed the pipe in and put a bit of PVC weld around it. Needless to say, that's not an airtight joint, because every time the restaurant is busy, there's an odor. So they fixed that, and a week later I spent the night there with my family, specifically walking up and down this thing. You have dinner and every 15 minutes somebody else had to get up and walk over it and come back and report back. That was 3 years ago, October 3 years ago. Since then, no problems. So you often get little things like that, but it would have happened anyway. That's nothing to do with the plant, it's a vent pipe that's not sealed properly. Those things we need to take into account. The same guy owns 5 of these campsites. You pitch your tent here right next to your pool. And there's your air pump and your panel. So think of a noise factor. You don't want to sleep in nature with a noisy thing next to you. You don't hear that air pump there. That's how quiet it is. This is the Kango Caves. Here you can see a different way of boxing it in the mountain, not having a bolt structure, but just a retaining wall. And they save 3.5 million liters a year that used to be thrown away. They now recycle on site for toilet flushing and for garden irrigation. Vrolikheid Nature Reserve and the Hoop Nature Reserve. So again, you see the case studies. At Vrolikheid, again, they use this treated effluent. You see the booster set there. They flush the toilets in the accommodation houses. That used to be staff houses that have now turned into accommodation for the public, and they irrigate the gardens around the houses with the treated effluent. There's the WIP 3 systems in there. So there's a few good cases if you look at environmental affairs, if you look at the restaurant, if you look at the nature reserves. Then Bonnie Park, Rhinefield, Bonnie Park, Benoni, where now both in the case of Kango Caves and Bonnie Park, the municipality actually bought the systems and installed them. So are they accepted? That answers your question. And the entire system is running off solar. There's no electricity supplying to the ablutions. So the entire system is running off solar. So you can see this is also 15 kiloliters a day. At high strength, we bring it down to 7 kiloliters a day. So we've got 7 kiloliters a day running off those few solar panels there. Just to give you an idea what we're looking at. And then if you need alternative water, and we're coming back to this midstream recycling just now, you can actually have the municipal sewer line as a source of water. If you need non-potable water and you don't have enough. This may take some negotiating with some of the municipalities. So I'm saying it is technically possible, but obviously you have to get permission to do that. So if you look at your circular water economy, then you will have your wastewater going into the system, treated and then taken back for toilet flushing and back for your garden irrigation or other non-potable applications. So there already we're talking on-site, we're talking micro, we're talking green economy, we're talking circular material flows. This is typically how we do that with water. This is just a schematic of what this is in fact a Vrolikheid Nature Reserve. We have your inflow, you have a splitter through the screen to 2 systems there, the UV disinfection pumped up to the holding tanks, the booster pump set filters, and then you split off to toilet flushing and to the irrigation system. So this is typically what your installation will look like. The holding tanks can also be below ground, they're just more expensive, but if the visual is a problem, they can also be below ground and you don't have the visual impact. So organic wastewater is not a waste, it's an asset. When you came here, you saw wastewater as a problem, either as a problem to handle it, or as a problem that you can't develop, right or wrong? Do you think a little bit different now? It's an asset. Reduce consumption, recycle, reuse. And it becomes a very, very valuable asset. At the same time, we reduce pollution and we bring water security. Ladies and gentlemen, thank you very much. Thank you for listening to me.